Hello friends, welcome to Maths Practice. In the last video we had seen all the key concepts of arithmetic progressions with examples. In this video we are going to see some more important practice examples for arithmetic progressions. Before we start, please do not forget to subscribe to Maths Practice. Example 1. For what value of k are the numbers x, 2x plus k and 3x plus 6 three consecutive terms of an arithmetic progression? Now we know that if it is an arithmetic progression, the difference between the two consecutive terms will remain same. So the common difference D is 2x plus k minus x, which is same as 3x plus 6 minus 2x plus k. Now if we solve this equation, we get the value of k as 3. Second simple example, the 17th term of an AP exceeds its 10th term by 7. Find the common difference D. Now we know the formula for the nth term of an arithmetic progression is an is equal to a plus n minus 1 into d. Now we know that the 17th term means for 17th term the value of n is 17. So a plus 17 minus 1, which is 16d, minus the difference between 17th and 10th term. So the 10th term will be a plus 10 minus 1 into d. So actually we have a plus 16d minus a plus 9d, which is given to be 7. So d is 1. Example 2. A sum of 700 rupees is to be used to give 7 cash prizes to the students. If each prize is 20 rupees less than its preceding one, find the value of each of the prizes. Now since we are given that the common difference is 20, means actually the second term of the AP is less than the first term by 20. So the common difference is actually D is equal to minus 20 because it decreases by rupees 20. Also we are given that S7, there are 7 prizes to be given. So the sum of all the 7 prizes is given to be 700. So S7 denotes the sum of the first 7 terms, which is 700. Common difference D is minus 20. The formula for sum of n terms is Sn is equal to n by 2, 2a plus n minus 1 into d. Putting the values, 700 is equal to n is 7. So 7 by 2, 2a plus 7 minus 1, which is 6, into common difference minus 20. Solving this, we get a as 160. So now the first term is 160, the common difference is minus 20. So the 7 prize amounts will be 160 minus 20, 140, 140 minus 20, 120, and so on, 180, 60 and 40. Example 3. A spiral is made up of successive semicircles with centers alternatively at A and B, starting with center at A. The radii are 0.5 cm, 1 cm, 1.5 cm and so on. What is the total length of such a spiral made up of 13 consecutive semicircles? Remember, take the value of pi as 22 by 7. Now from the figure it will be clear what is to be said. There are semicircles whose centers are alternative at A, B, and so on. We have to find the total length of the spiral, which is made up of 13 such semicircles. So now let us assume that the length of the respective semicircles are L1, L2, L3 up to L7 with the centers alternatively at A, B and so on. Now we know that the perimeter of a circle is 2 pi r. So the perimeter of the semicircle would be 2 pi r by 2, which is pi into r. So the length of the spirals will be pi into r with the respective values of radii. Now, so the arithmetic progression for the lengths of the semicircle will be pi r1, pi r2, pi r3, and we want up till pi r13. So the sum of the lengths of the semicircle would be pi r1 plus pi r2 up to pi r13, which is equal to, taking out pi common, r1 plus r2 plus up till r13. We know the formula for sum of the n terms is n by 2, 2a plus n minus 1 into d. Now, so the sum of the radii would be R1 plus R2 plus R13. Now we know that R1, R2, R13 are the terms of an arithmetic progression with the first term 0.5 and the common difference is also given to be 0.5. So putting the values, S13 would be 13 by 2, 2 into first term 0.5 plus 13 minus 1, 12 into common difference 0.5, which is 13 into 7 by 2. So now since we need the sum of the lengths, it will be as given above, pi into the sum S13. So pi into 13 into 7 by 2, which is equal to pi, we put it as 22 by 7, which is 22 by 7 into 13 into 7 by 2, which is 143. So the sum of the lengths will be equal to 143 centimeter. Example 4. Find the sum of first 40 positive integers which are divisible by 6. Remember, these type of short questions can also be asked as MCQs or in short questions. Now the arithmetic progression would be the positive integers which are divisible by 6, means we start from 6, 12, 18 up to 40 terms. Now the sum of the first n terms is Sn is equal to n by 2, 2a plus n minus 1 into d. So S40 is 40 by 2, first term is 6, so 2 into 6, 12 plus 40 minus 1, 39 into common difference will be 6. So the sum of the first 40 terms would be 4920. Similarly, another example. The first and last term of an arithmetic progression are 17 and 350 respectively. If the common difference is 9, how many terms are there and what is their sum? Now it is given that the first term is 17 because it is given first term 17 and last term L, which is given to be 350. The common difference D is 9. The formula is An is equal to A plus n minus 1 into D. L or the last term is the nth term, so An is 350, which is equal to 17 plus n minus 1 into difference 9. Solving this, we get the value as n is equal to 38. So as 38, the sum of the 38 terms would be 38 by 2, 34 plus 37 into 9, which is 6973. So we have found out that there are 38 terms and their sum of the 38 terms is 6973. Example 5. The fourth term of an arithmetic progression is 0. Then prove that the 25th term is 3 times its 11th term. Remember, these type of examples can also be asked in the exams. Now what we are given is that we know that the nth term of an arithmetic progression is An is equal to A plus n minus 1 into D. We are given that fourth term is 0, means A4 is A plus 4 minus 1, which is 3 into D is equal to 0. So one equation which we have is A plus 3D is equal to 0. Now we have to prove that the 25th term will be A25, A plus 24D is 3 times its 11th term. Now first of all, let us take what is 3 times 11th term. 3 times 11th term will be 3 into the 11th term, A plus 11 minus 1, which is 10 into D. So 3 into A plus 10D. Now we can simplify this as 3A as A plus A plus A plus 30D. Again we can write this as A plus 3D plus A plus 3D and remaining is A plus 24D. But we know that A plus 3D is 0. So it is 0 plus 0 plus A plus 24D. From above we can say that this is equal to the 25th term. So we have proved that 3 times the 11th term is equal to the 25th term. Example 6. The ratio of the sums of the first m and first n terms of an arithmetic progression is given to be m square is to n square. Show that the ratio of its mth and nth terms is 2m minus 1 is to 2n minus 1. Let a be the first term and d be the common difference. Also we know that the sum of the n terms is given by Sn is equal to n by 2, 2a plus n minus 1 into d. Now what we are given is the ratio, means the division of sums of first m terms and first n terms. So m terms would be m by 2, 2a plus n minus 1 into d upon n by 2, 2a plus n minus 1 into d. This is equal to m square by n square. Now when we simplify this, from the left hand side the 2 gets cancelled. We have m upon n and here m square upon n square. So one of the m upon n will get cancelled. So now what we have is 2a plus m minus 1 into d upon 2a plus n minus 1 into d is equal to m upon n. Now cross multiply. So n into 2a plus m minus 1 into d is m into 2a plus n minus 1 into d. Bring the terms having a on left hand side and d on right hand side. So when we simplify, we get 2a into n minus m is equal to d into n minus m. So n minus m gets cancelled out. We have d is equal to 2a. So first of all, what we have shown from the given is d is equal to 2a. Now we have shown that d is equal to 2a. Now the nth term of an AP is given by an is equal to a plus n minus 1 into d. We know this formula. Now what we have to show is the ratio of the mth term is to nth term. So let us find out am upon an. Am upon an will be a plus m minus 1 into d upon a plus n minus 1 into d. Now just put the value of d as 2a. After simplifying, we get 2am minus a upon 2an minus a. Taking out a common from numerator and denominator, we get this equal to 2m minus 1 upon 2n minus 1. So what we have shown is the ratio of the mth and the nth term is 2m minus 1 is to 2n minus 1. Remember, these type of ratio examples are also asked. Next interesting example. There are 8 houses numbered from 1 to 8. Prove that there is a positive integer n such that the sum of the house numbers preceding this house and the houses following it is the same. Find that n. Now what is given is there are 8 houses 1, 2, 3, 4 up till 8. We have to find a number from that n such that the sum of the houses before that number and the sum of the houses after that number is same. So that n we have to find out. Now it is given that it starts from 1. So a is 1 and the common difference d is 1 because 1, 2, 3, 4, 5, 6, 7, 8. What we are given is the sum of the houses preceding that n. So if suppose n is that number, the sum of the houses preceding that will be 1 plus 2 up till n minus 1. And the sum of the houses after n means n plus 1 plus n plus 2 up till 8. These two sums are equal. Now just try to simplify this right hand side. It is n plus 1 plus n plus 2 up till 8. So first thing what we have is 1 plus 2 plus up till 8. So it is 1 plus 2 plus 3 up till 8 minus, now on the right hand side we are taking terms from m plus 1. So we just subtract the sum of the first n terms from that. Why? Because we are starting from n plus 1. So this simplification is important to understand. The right hand side is simplified as first of all 1 plus 2 up till 8 minus the sum of the preceding n terms, which is 1 plus 2 up till n. Now we know the formula for the sum of n terms. It is Sn is equal to n by 2, 2a plus n minus 1 into d. For the left hand side, first term a is 1, common difference d is 1. So when we simplify that, the sum of the first n minus 1 terms, we get it as n into n minus 1 by 2. Now one more thing, this you have to remember. You know that the sum of the first n positive integers is n into n plus 1 by 2. But actually that is also based on arithmetic progression. For the sum of first n positive integers, a is equal to 1, common difference d is 1. So according to our sum formula, it is n by 2, 2 plus n minus 1 into 1. So when we simplify it, we get n into n plus 1 by 2. So everywhere for the sum of the first n positive integers, it is given by n into n plus 1 by 2. Now if we put the value of n as 8, we get it as the sum as 8 into 9 by 2, which is 36. So remember that for n is equal to 8, the sum of the first n terms is given by 36. So now what we have is, the left hand side is 1 plus 2 up till n minus 1, the sum of the first n minus 1 numbers, which we know it is n minus 1 into n by 2. Right hand side is 1 plus 2 up till 8, means the sum of the first 8 positive integers, which is 36 as we have found out, minus the sum of the first n integers, which is given by n into n plus 1 by 2. So we just try to simplify this. This simplification is simple. We get n square minus n is equal to 72 minus n square minus n. So after simplification, we get n square as 36. Obviously, n will be a positive integer, the numbers. So n is equal to 6. Therefore, all the houses preceding the 6th house and following it will have the same total number of house numbers. What does this mean? That before 6 means 1 plus 2 up till 5. This total is 15. And after 6 means 7 plus 8. This is also 15. So 6th house is such a house such that the sum of the numbers before that is same as the sum of the numbers after that. Now some assignment examples of different types. First one, in an arithmetic progression, the sum of the first n terms is given as 3n square by 2 plus 5n by 2. Find its 25th term. So you just have to apply the formula for the sum of the n terms and then the nth term. The 25th term answer is 76. Second one, a man purchased an item for $32500. He paid $200 initially and increasing the payment by $150 every month. How many months did he take to make the complete payment? So the initial amount is given and it is increasing every month by 150. So it is an arithmetic progression. You just have to find that value of n, the number of months he takes to complete the whole payment of 32,500. The answer is n is 19. Which term of the AP 3, 15, 27, 35, 39 and so on will be 132 more than its 54th term? So first of all, find its 54th term, add 132 and then try to see that which term gives this total. So you have to use the sum of n terms formula and the answer is 65th term. How many multiples of 4 lie between 10 and 250? Multiples of 4 means obviously the common difference is 4 and the starting term is 10. So just the answer you have to find out is 60. Fifth example, two cars A and B start from the same point and at the same time. A travels at a constant speed of 10 km per hour, but B starts with 5 km per hour and every hour its speed increases by 0.25 km per hour. After how many hours will B overtake A? So now the speed of B follows an arithmetic progression with the starting value A as 5 and the common difference D as 0.25. Now you have to find out after how many hours will B overtake A. Means the hint is, if the time taken by B to overtake A is T hours, then at that time T hours, both will travel the same distance. So just equate the distance traveled by both of them at the time T. You will get the answer as 41. After 41 hours, B will overtake A. Friends, if there is any query, you can write in the comment section. We can solve it. Friends, we have seen different types of important examples on arithmetic progressions. Please do like and share this video and subscribe to my channel Maths Practice for many such other videos on class 10 Maths. Thank you.